Yeah, great to see you all here. And I'm sorry, I know you were expecting talks about code, about web performance, but we're going to talk about slugs. And the problem is no one really likes slugs because they're slimy, they're pretty ugly, except for maybe their eyes, dangling, and they're just very slow. So you really don't want to have slugs like on your hand, for example. You don't want to have slugs on your phone. And of course, you don't want to have slugs on your web page. And why is that? Well, here's a little example. Okay, say I have an interaction on my web page and it's very, very quick. So, I click on a button and I see a response immediately. And that's what I expect when I see elements on the web page. So if I have a response time under 0.1 seconds, then I'm happy. I know I'm in control as the user. And the problem is if I have some more JavaScript kind of keeping things occupied in the browser, keeping my machine working before I get the response of my interaction, then it kind of slows things down. Then I'm not as happy. And so a response time between 200 milliseconds to a second, then I start to think as a human, okay, the computer's working. It must be busy doing something, right? And so if I really slow it down, now I have 2 million operations, 2 million times going through this loop. Now I have a response time over a second, say, and now I'm annoyed as a user. And so this is important if you're, say, for example, on an e-commerce site and you want to add a product to a basket and you just don't get the response you expect. Or maybe you end up clicking something and then something happens or it freezes and then you end up clicking the wrong thing. You don't really want that to happen. But this example right here, that was on my Mac. It's an M2 with an M2 chip. So what happens if you slow down the whole thing? So here I have a 4 times slowdown in DevTools. And now basically with the same interaction or the same number of operations happening between the input and the response, basically the interaction or the page is unusable. So a wise person said, it's a completely made up Chinese proverb, of course, a dragon in one hand is a slug in the other. So basically, even if you test out things on your own devices, you always want to keep in the back of your mind, okay, not everyone is using a quick MacBook or a quick iPhone. Actually, more than likely, a slower device. So we have to think about slower devices and slower response times. So speaking about response times, how do we measure that? Well, there are various metrics that we've used in the past. And of course, I would like to talk about INP. That's going to be a new core web vital in next year that will replace first input delay. What is INP? INP is a metric of the overall responsiveness of a page. So during the entire page life cycle. So any interactions due to click or tap or keyboard interaction, those are going to be measured. And so basically INP says, okay, if I maybe clicked on the page a bunch of times, what was the slowest interaction? And so what is considered slow? Basically an interaction under 200 milliseconds in this case is considered good. Between 200 and 500 milliseconds needs improvement, and above that is poor. So let's take a look at this. Here's the hand of God clicking the big red button. So God clicks on the button, and we may have an input delay, for example, and then we have the click event occurring, and some processes that happen to do whatever work has to be done to process this click. So we have the processing time there. And then we might have some rendering and some painting work that needs to be done there before, ta-da, the big display of the next paint, basically, INP. So INP, like I said, it's taking a look at all the interactions on one page. So say, for example, I might have some shorter interactions, or I might have some longer interactions. So basically, currently the metric is well, it depends on the number of interactions. So it could be the slowest, or if there are very, very many interactions on the page, it could be the 99th or the 98th percentile. So how do we measure INP? Well, here's a little short snippet in JavaScript. So basically what we do is register a new performance observer, and it watches for the type event, so that it is based upon the event timing API. And we check basically if there are any entries, performance entries with interaction ID, then we process or calculate the duration, and then we log that out, for example. But keep in mind, the event timing API is still not available or supported by Safari. And interaction ID is only available in Chromium browsers. So of course, next year when people start talking even more about INP, you got to keep this in mind. Okay, what browsers can we even measure that with? So if I measure this,
can I ask a question?
Well, I'd like to get to those at the end.
Okay.
Yeah, but so basically, if we measure, INP in JavaScript, this is an example of the output. So here I see the click event, I see the duration, and so forth. We alternatively could use the Web Vitals JS library to also capture INP. And what I can get with that is, for example, the various elements, the selectors, the elements that were clicked that related to these long interactions. And a bunch of other stuff, of course, in the library. And Google recommends, for example, if you're going to track INP on websites and send the data to your real user monitoring to your RUM, then you want to send the INP value, so the numerical value, the attribution, so the element selector, what element was clicked, also the loading state of the page. Was the page fully loaded, or maybe it was an early interaction before the page was loaded. The interaction start time. So obviously when you load a page, everything is being processed at the beginning. If there are very early start times, then we know, okay, people are seeing elements on the page, they're starting to click, and it's probably pretty slow then. And also the event type, if it was a click or whatever event. So we're going to talk about how to deslug INP. And here's some common slugs. So some common problems here. So we have long input delay, event callback, and presentation delay. It's like I showed beforehand. You could have an input delay, like whenever processes are already running and the main thread is just blocked and it can't process the interaction. Or we might have slow event callbacks. So like in my prototype with the snail, just a lot of work going on, and the event couldn't just have a callback and the response in the end. Or we could have presentation delay, too much rendering work, recalculations happening there. So how could you go about debugging RUM or debugging INP in RUM? Well, this is what I have tried to do so far is, for example, take a look at different page types and calculate which percentage of interactions were good, needs improvement, or poor for the various page types. And first of all, seeing, okay, here in this example, the very top is very red. So I would probably look at that first, especially if it's a page that has a lot of traffic, or if it's in the money path. And then I could go a little bit further and have a look at, this is an example with attribution using largest contentful paint, not INP, but it's the same principle. Basically having a look at all the different selectors and seeing, okay, which were the highest percentage of occurrences of these selectors. So basically, which were the slowest clicks on which elements on the different pages. Yeah, so my recommendations in this case, so far, what I've found out working with this is, first of all, focus on mobile. Like I said, beforehand, you're obviously going to have slower interactions on slower devices, and in this case, it's also mobile. You could create try-bin charts, like I have here, and prioritize high traffic pages or the money path, and then use attribution to find the culprit in your data. Yeah, so now we're going to have a look at INP in the browser. So how can you de-slug in the browser? There are a bunch of different tools, and I'm going to cover each of those. But first of all, some basics. So like I said, you want to take a look at mobile. So you could set responsive mode and select a device. Use a browser profile without any extensions, because you don't want to be debugging and you have extensions kind of muddying everything up. And then you want to set some processor or network throttling, so you can kind of emulate what might be going on in the real world. And then also, for example, in the EU or in California, accept cookies, because we know then a lot of trackers are likely to be added. A lot of third-party stuff is going to be started, so that also obviously has an effect on performance. Secondly, what I like to do is get a baseline. How does the page load? How is responsiveness without even interacting with the page? If there's a lot of work going on in the baseline, then I can kind of try to deal with that in the first step. So how much main thread work is there without interaction? Maybe have a look at total blocking time, the amount of code that's being used, and I'll show that in a sec, and the effects of third-party code. And thirdly, the interactions themselves. So for example, I tend to look at above the fold elements. So if the user goes to a page and sees maybe a filter button or a big buy now button, then those are likely to be commonly clicked elements. And then start also quickly clicking different elements, or rage clicking, because that also has an effect on interactiveness or responsiveness. So here I'm showing you how to do that in the DevTools Performance tab. So without an interaction, I'm just go to the Performance tab and reload the page, basically. And so it takes a couple seconds usually. And then I can see, without even interacting, I see the long tasks. So what we see there in red, the longer the row, the longer the task, basically. And then I can use that information to kind of drill down and see, okay, what are the responsible scripts, or what was leading to that? What caused that? And to measure an interaction, then I just immediately start recording the performance trace, and then just do a single interaction. And then I can see, in this case, it was it's kind of hard to show. On this screen, it's the little orange. Yeah, sorry, it was too slow, but you can see in this trace the where I interacted and then where the tasks start happening. So now I can drill into the source code and can start looking on from there. Okay, is there something to do with, some words that jump out is hydrate. Let's see, what document are we? We're in the framework document. So maybe it must have something to do with the framework and rehydration or something like that. So it just kind of gets my foot in the door there. You could also use the Lighthouse time span mode. So this is kind of relatively new, I think from this year. And so basically it does a similar thing. I just click record, interact with the page, and then I get basically an audit and recommendations. I see total blocking time here in this case, interaction to next paint. And when I scroll down, I get different recommendations, things I should keep an eye on. Here I see my selector, the element that I clicked, presentation delay, processing time, input delay, those 3 performance slugs that I mentioned. So that could also be very helpful. And this is one thing that I love to use. Not many people use it regularly. It's the Performance Monitor tab. And so this shows you in real time CPU usage, number of DOM nodes, JS event listeners, style recalcs. And so basically I can also just start interacting with the page and I can see peaks. And yeah, I'll mention something interesting about this a little bit later. And also relatively new is the Web Vitals extension. You could download an extension in the Chrome store, enable Chrome logging, and then you can also just start interacting with the page. And here my console is very, very busy. So you could also filter down, say, for example, vitals in, so I can just see the interactions. So that's also kind of helpful. Then I can see what's green, what's red, just by interacting with the page. And here I also see the subparts of the interactions. The DevTools coverage tab is very helpful for seeing the percentage of unused code. And this is during a page reload, for example. So I reload the page. I see, in this case, a huge amount of code from Facebook that is responsible for, it's also keeping things busy. And so that might be a candidate for either, you might want to consider, do I need that anymore or do I not need it? What happens if I block this request, maybe run another performance trace and compare? So this is also a good place to look. You could also take a look at page responsiveness or also, interaction numbers. In this case, total blocking time using, for example, web page test. And this helps you, at least if you don't script a test, if you script it just so that you just see the page load, then you can see, okay, how much code is loaded just when I start loading the page. And so that might give a good indication on this input delay, for example. Here, for example, I see the red at the bottom. That's all, those are long tasks. So we see the main thread very, very busy right here. And we see a bit later on that it's not so bad. So what does that mean? Does that mean if the user starts interacting right there, am I going to have slow interactions? Yes or no? One thing that helps is go to the film strip view, and then you can just scroll through the film strip until you get to the point where you see elements on the page. Because obviously, the user's probably not going to click around on the page until there are visible elements. So here I have visible elements, but the red line at the end, that's showing me, oh, okay, but actually all these long tasks, they were before that. So it is probably not so bad. Okay, so those were a few different tools that could help you to deslug INP. Now let's go on a slug hunt. And I'm going to show you a couple of examples of things that I've come across. Let's start out with my prototype. So I enabled local overrides, and I slowed down my CPU, and then I just record a single interaction. And so I first have my baseline. I see there's a very, very long task. Now I click into the source code. And now because I have local overrides enabled, I can just comment out this for loop, the thing that's responsible for all this browser, this blocking task, all this work. And then I reload the page. And then I run another performance trace here. And now I can compare, and I see, oh, okay, that seemed to be the problem. Awesome. So I know what's wrong. So now I have a place where I can start to improve, refactor my code, maybe think about changing the whole way the app is working at that single point. Do I really need to go through all those operations at that time or not? So let's refactor the code. So I go back into the sources. I'm going to just paste my refactored code in there. And then I save it, refresh the page, go back to the performance tab, and then I run a performance trace, interact with the page. And let's see how that works. That was also pretty quick, it looked like, huh? And so not bad. Awesome. So I really cut down that total blocking time with my refactored code. Let's see what kind of code that was. So I have my for loop there. And like we already said, that's a long task. So we spotted our first slug here. We have a very slow event callback. How could I get rid of this slug here? So what I can do is yield to the main thread as often as I can, or whenever it makes sense. Because actually, whenever I have the interaction, the click, I want to have the reaction as soon as possible. So what I'm going to do is just immediately toggle my class so I can display the change. And then I yield to main. And then I do whatever work I need to get done. So I yield to main using a new promise and set timeout. And then I do the work. So in this case, also I kind of changed that up. Instead of continually calling or getting the class list, I'm just calling it once, and then I start my loop. And then I'm seeing, okay, is the class list the same as it was or not? If it's not, then I set it. So I'm doing a lot. Obviously, it's just a prototype, just a fake situation here, but just showing you want to yield to the main thread so the main thread can do more important work. So here's another here's a real life example that I came across on a website. And interestingly enough, whenever I went to this certain web page, and that was also on my MacBook, previous one, I noticed that the longer I was on the page, like my fan would start to go, and then eventually it started like I thought it was going to hover above my table, and so I ran a performance trace, and okay, there's a lot of stuff going on here. And anyone notice this long purple bar? And that's animation work being done. So what does that look like? That's how it looked. Yikes. So all this, there's tons of animation work being done here. That's very, very expensive. So, spotted 2 slugs here. Long input delay, presentation delay, yikes. And it turns out it was a simple little animation. In this case, that was responsible for that. Skeleton animation, linear, infinite. So it was continual animation. So I just toggled that. I had here the performance monitor on to see what the effect would be. And obviously, with the animation, CPU usage was very high, maximum. And then without the animation, basically 0. Awesome. So what was responsible for that? You must have seen something like this before on websites. If you're loading a web page, e-commerce, for example, skeleton loading, basically, it's a placeholder in the layout to let the user know, okay, you might not see the animation so good here. Oh, sorry about that. It's a bit grayish here. Here, it's also supposed to be gray. But basically, it's a placeholder in the layout to let people know, okay, something's loading, something's happening, because it's a good way to just distract users so they don't get bored too easily or leave the site if it takes too long. So the problem was, though, that skeleton loading was happening on a very, very long category page with hundreds of product tiles. And so even tiles that were way below the fold, you know, miles and miles of pixels, way below the fold, they were causing the main thread to just run and run and run. So obviously, skeleton loading can kill rendering performance. So it's not to say don't use skeleton loading, or skeleton loading can ruin all websites, but rather just be choosy of where you do that exactly and when. So another finding from the wild, tag managers also can hurt performance. Obviously, you know, you're loading third-party code in a tag manager, and then you're giving people in your organization a door to just load additional code. So, for example, if you maybe have the tag manager, you've had it on your website for many years, people don't look and use it regularly. They just keep adding different tags, different tracking pixels, different tools. And so all this code is just bloating. And that leads to code bloat, a lot of unused code, for example, and of course, how these tags are triggered. So say, for example, all the tags on the site, they're just listening to this click event. Oh, that's going to be very costly. So here's another example that I've come across recently. Clicking on the filter button, I noticed that was also a very slow interaction. What's the problem there? Ran a performance trace, and I see, okay, one interaction there. That's that orange line I was telling you about. It's orangish, yeah. And a lot of long tasks in relation to that. And so I drilled into the source code, and I noticed this GTM click, so Google Tag Manager click. And so I just playing around with this, using local overrides again, I just wrapped that in a set timeout, and did another performance trace, and we see way fewer long tasks in this case, and the interaction was way quicker. So it's not to say that that's the perfect solution for this case. It's just to say, okay, watch out how tags are being loaded in the tag manager. Maybe you need a different trigger. Maybe it's when you leave the page, then you can send off the beacons or whatever. And to kind of wrap things up, yeah, this is something I posted on Twitter a year ago, almost to the day. And you know, INP's been around for a couple of years now, but it's only now going to be a core web vital in next year. But I think it's going to be a very difficult metric to improve, because it's maybe not like largest contentful paint, where you might have maybe more of the developers in the game, or maybe the UX, UI designers in the game, or with layout shift. You know, that's more of a developer-focused metric. INP is something that, you know, like I said, if we have marketing also adding tags without any kind of check, that's going to ruin INP. Obviously, the engineering department, if they're just adding continually nonstop JavaScript, that's also going to have implications. And I think Eric's going to talk about that a little bit. So optimizing responsiveness is hard. It's going to be hard. And with that, I have a couple gotchas. So it sounds like a good thing, a good metric to keep an eye on. But the thing is, INP on single page applications is going to be kind of tricky. For example, if on a single page application, you don't have the navigations to kind of tie the interactions to, then that'll obviously make debugging a little bit more difficult. Watch out for iframes. Due to content security policies, we cannot track or capture the interactions in iframes and then send that to our real user monitoring. But we can see that in the crux data, in the Chrome user experience data. Keep an eye on browser support. Like I said, no Safari or Firefox on at this time for INP. Obviously, not every page is going to have an interaction. Might want to keep that in mind. And to finally end this thing, we have definitely want to track INP and RUM. There are the tools out there that I mentioned, so we got to start doing that. Test interactions on slower devices. And keep in mind, whenever you have components on a web page that are recurring, like product tiles, those are great examples. So if you have a performance bottleneck on a recurring component, obviously those performance bottlenecks are going to be multiplied the more of those components you have on a page. Animate with care, so watch out for skeleton loading. Just know what's being animated, what's not being animated. Audit your tags, check your tag triggers. And yeah, thank you very much. Now, give me 5. Awesome, thank you. So any questions? Yeah.
First of all, thank you for this excellent talk.
Thank you.
Wow, I'm quite impressed. One question I have, you changed the callback inside the event listener to be an async callback. So
yeah.
Basically, you're creating a promise. By creating this promise, you're putting like what's happening inside the closure of the function on top of the call stack of the event loop. So basically, by just moving it to a promise, you are moving the work that needs to be done out of the critical path of the event. Are the Chrome Dev tools able to track these?
I'm sorry.
Because it's not in the same call stack. Imagine you have like 5 more items in the call stack. Now you trigger an async event. So the work that needs to be done is put after this, so outside of your flame graph. And are the dev tools able to correlate these back to the original event handler?
Well, the way I understand it is that promises are considered micro tasks.
Okay.
So yeah, basically it is like a different stack, but the good thing is with the promises is that the event loop will get those as soon as there's time to do it.
So in comparison to set timeout, these set timeout may be delayed even further, and the promise is being called earlier, right? Because it's a microtask.
I don't quite know. I'm sorry.
Okay. No problem. That's it.
Yeah.
Thanks. That was one thing where I was not sure if the tracking of the flame graph of the dev tools actually are able to correlate this back into the flame graph.
Yeah, that's a very interesting question. Yeah, okay. Didn't really think about that. Yeah.
Thanks. But you basically answered.
Okay. Yeah.
Can you jump back to the slide where you did tell us basically how we can basically track INP?
Yeah, sure.
Maybe you can repeat the question.
Yeah, so the question was to go back to how we can track INP. No?
I'm curious about 2 slides Or is it right?
Well, that's maybe an important thing. Yeah. So if you're measuring INP in JavaScript, like I show here, I wouldn't recommend you sending this data to your RUM, but rather using the Web Vitals JS library. And I don't know, I'm sorry, there's some more work that goes on under the hood with the Web Vitals library compared to this right here.
Yeah. My question was basically, what does the duration threshold mean? So
Duration
the
threshold,
parameter
yeah.
at the end, so.
Yeah, so the way I understood it is if there's a duration threshold, you know, if there's an interaction that's less than 16 milliseconds, then it's not going to be tracked in this case or logged to console. Yeah.
Okay. Thanks.
Mm-hmm. Yeah.
Yeah. So also kind of related to the first question about us. So you did like you said it's better to leave to main early on. And so yeah, I'm thinking about some experience I had earlier and did not know what to do with it. So like so if you yield to main earlier, the first main can happen, but then the work has to be done later. So main is also blocked later, right?
Yeah.
And this might also block other interactions for the page. So my experience was like, okay, maybe the first like thing was happening, but then all interactions afterwards are very slow. And yeah, so this like could also be just cheating with this metric and not really actually improving the user experience.
Yeah.
So what do you like?
Yeah, so the question was, so does it mean, what are you going to do with the work that is going to end up blocking the main thread? What do you do with it? If you just defer it to later on, I mean, it still has to be done, right? That's a very tricky question, and I'm sure you can't really just give a general answer to it. It's probably like a case-by-case basis. Tricky one. I mean, I think the general recommendation is to, I mean, from a user perspective, if I interact with the page, I want to see the response as quickly as possible. So if there's work that still has to be done, is there any way to decouple that from the presentation? Is there any way to maybe abort the work that's being needed to be done? Maybe if the user clicks cancel, do I still need to run the 1 million loops, for example, in my case? Yeah, so I did link some of the slides to the most of the documentation or the resources are on web.dev, and they also have recommendations for how to approach that. Yeah, so deferring work, aborting it, and so forth. Yeah.
From the React community, and when we're talking about like the new changes, their solution to this question is often to prioritize the work that's very important, and the other work that's not that important, you will put in a different thread, so you can accept like bottlenecks in there. But the important parts, for example, typing inside a text input, this will be preferred because it's not that annoying to the user. So you need to decide what's more important, and then you prefer that.
Yeah.
For example, by suspending or that's how the modern frameworks have their answer to this question.
Yeah. Yeah, very interesting comment, you know, regarding React, and then how to prioritize work, you know, just considering what are you going to prioritize. And I think it's also interesting with, for example, product tiles on category pages. If they're all being hydrated with React, I mean, do I need to hydrate everything that's below the fold, or can I do that progressively? Yeah, awesome. So it's kind of hot in here. I would say let's take a quick break, and then we'll come back with Eric's talk.